Okay, today we want to continue our discussion on solids. We want to talk about congruent and similar solids. And I apologize in advance for any coughing I may do. I'm still having a little bit of this stuff, so I'm trying desperately not to interrupt this with that. Actually, this is a very simple concept and topic. We're going to divide it into two pieces. And the first one's pretty straightforward. Congruent and similar solids. Let's talk about the congruent pieces. Two solids are congruent if meet four conditions. Number one, the corresponding angles are congruent. Congruent means same shape, same size. What determines shape? The angles. What determines size? The length of the measurements. So therefore, in order to be the same shape, the angles have to be congruent. The corresponding edges are congruent. Well, now we're getting into the size, aren't we? In order for them to be congruent, their size has to be the same. Therefore, their lengths of everything have to be the same. Corresponding edges are congruent. The corresponding faces are congruent. And the volumes are equal. In other words, everything about those two solids are the same. Same shape, the same size, the same volume. We pour something into it. We can pour it from one to the other without losing any, without putting any more in, whatever else. The area of the faces is all the same. The surface area is the same. The perimeters are all the same. Everything is the same. That's what congruent means. So, in order to determine if two solids are the same, are congruent, everything has to be the same. Look at them and make sure everything is the same. Make sure the measurements are the same. Make sure the angles are the same. The shape is the same. And then it's congruent. That's pretty simple. Okay? So that takes care of congruency. I'll let you figure out on the problems which ones are congruent or not. I think they're pretty simple. Now let's talk about the similar solids, because that's obviously where most of our work's going to be, and most of our problems are, and where our algebra is going to come in, and where we're going to have to do work. Let's get this spelled right. Similar. Excuse me. Let's read this. Two solids are similar if corresponding angles are congruent. Remember, similar means same shape, different sizes. Same shape means they have to have the same angles. Why? Because angles are what determine the shape. Angles determine shape. Okay? All right. So for them to be similar, corresponding angles are congruent. And the corresponding linear measures are proportional. That's the same way as saying sides. The edges, the faces, they are proportional. Okay? Think about the similar triangles we've done. We're looking at that sort of type of thing. Also, if two solids are similar with a ratio or scale factor of A to B, then their surface areas have a ratio of A squared to B squared. And their volumes have a ratio of A cubed to B cubed. Now think about that. That makes sense. Why? Because linear measurements are just single dimensions, A and B. What are areas? They're two-dimensional, aren't they? They have length and width. Therefore, they're squared. Inches squared, meters squared, centimeters squared, miles squared. Okay? So therefore, we have to square the linear measures, or linear ratio, to get the ratio of their surface areas. Their volumes are cubed. Feet cubed, meters cubed, centimeters cubed, milliliters cubed. Okay? Milliliters is a volume. Okay? Miles cubed, big surface area. Yards cubed. So therefore what we're looking at is their volumes are cubes of, or to the third power of the linear measurements, or the linear ratios between the two. Okay? That's the ratios. So what does that help us with? Well, if we know what their linear ratio is, then we can determine what their volume ratio is. So if we know the volume of one of them, we can determine what the volume of the other one is. If we know the surface area of one of them, we can determine what the surface area of the other one is. Okay? All right, now we need to do a few problems, and we'll be done.